In this video, we're going to be tackling the LeetCode question, remove nth node from end of list. So if you haven't noticed already, LeetCode questions that are very old tend to be very popular. And being that this is number 19 in LeetCode's list, this is a popular question, and for what reason, I honestly don't know. But I'm not hating, because we're all out here trying to do the same exact thing. We're trying to do less work in our code, that is. We do things like try to get the time complexity down. We cache. We use all types of crazy patterns to try to do less work and get the same result. But one thing we haven't talked about yet is one pass and two pass. One pass and two pass is slang. It's lingo to denote the number of loops that we use. And one way that we can optimize is we can one pass as opposed to two pass. And that's the whole theme of this particular question, and why I think people ask this question, because it's a trap. It's a trap question. They want you to two pass in this question, but we don't want to two pass. We want to one pass. And it's very tempting to two pass because if you think about it, if we want to remove the nth node from the back of a linked list, and let's say that we want to remove the second node from the back, n is equal to 2 in this case. Therefore, we want to remove this node right here. One way that we could do this is we could just subtract the length by n. We could subtract the length by 2. But here's the thing. The length is not built into a linked list. Therefore, we're going to have to iterate through the linked list all on our own and find the length just by traversing and incrementing a length counter. Just one by one, we're going to have to go through the linked list till we get to the end and find the length on our own using one pass already. And in order to find and remove that nth node, we're going to have to do two passes to go back through and find it and remove it, which is not what we want and could cause us to potentially fail the interview. So what are we to do? What we're going to use is what's called the fast and slow pointer approach. It's pretty much exclusive to linked list, although you do sometimes see fast and slow pointers with arrays. But the name pretty much describes exactly what it does. We're going to have a fast and slow pointer. And we're going to model our linked list after a very dangerous cave. Let's just say these different nodes represent different places in this very dangerous cave. This cave is infested with dangerous bats. And we want to find a nugget of gold. We're digging for gold, and this gold exists at the nth from the end node. This is the node that we want to remove. We want to remove this nugget of gold from the cave. And what we're going to do is, since this cave is infested with bats, it's dangerous, and we definitely don't want to die while we're digging for gold. We're going to send out some young buck. We're going to send out some young kid who's not afraid of bats, and we're going to send him out n+1 places ahead. And what we're going to do is, we're the slow pointer. We're going to chill in the back, and we're going to incrementally traverse with the fast pointer. And we're going to keep traversing. We're going to keep traversing. And eventually, the fast pointer is going to get to the end. And once the fast pointer gets to the end, we will be at the node that we want to remove. And by utilizing fast and slow pointers, what we do is we get rid of the need for calculating the length of the entire linked list. And that gets us down to just one pass from two. Because all that we need to do now is initialize one fast pointer n+1 places ahead. So n+1 is equal to 3 because n in this case is equal to 2. And that brings us to the third node. Then what we're going to do is initialize a slow pointer, and this slow pointer and fast pointer are going to move in tandem at the same time until finally the fast pointer reaches the end. And by the time that the fast pointer reaches the end, this is the node that we want to remove, and boom, we just go ahead and remove it, and we have solved this algorithm. So let's go ahead, let's hop over into IntelliJ and let's code it. So we are inside of IntelliJ, and first thing that I'm going to do is create a brand new Java class. I'm going to call this list node. And this is just going to be the individual node for the linked list. You don't have to do this if you don't want to, but I like to do this because it's a good learning experience. And I'm going to create an empty constructor. I'm going to create a constructor that takes in an int val, and also I'm going to create a constructor that's going to take in a val and the actual next node. So that looks good. Let's go ahead, create a solution class for our algorithm. I'm going to name this solution, and we're going to house our method in this solution class. So this method is going to be public, of course. It's going to return a list node. We actually need to return the list node, and we're going to call this remove nth node from n. It's going to take in the list node as a parameter called head, and also it's going to take in n, which is the value from the back. This is the number from the back that you want to remove. So before we do anything else, what we're going to do is we're going to create what's called a dummy node. A dummy node is important because it prevents situations where the head is totally destroyed. If n were to land on the head, if we were to remove the head of this linked list, we'd be screwed because there's nothing to tie our pointers to, which is what we're about to do right now. We're going to create our pointers, and we're going to assign them to the dummy node, which is the new head in this case. And we're assigning them to the dummy because the head could possibly be removed. So we need that kind of dummy buffer there, so to speak. So we have our fast and our slow pointer. I'm going to call them first and second because there's one guy that's going out first, and then there's a person that's going out second, so to speak. And it's not really a fast or slow pointer, so I'm going to call it first and second, but feel free to name it whatever you want to. Then what we're going to do is we're going to need to do the actual incrementing. We're going to need to move the person, the first person that goes in, we're going to need to move him ahead n+1 steps. What we're going to do is we're going to create the for loop that's going to do that. We're going to say less than or equals to n. Then we're going to say I++ to increment. That's pretty much just our basic for loop. And this is going to be what moves the actual pointer. First.next is what does the actual movement of the pointer or the person, so to speak. Then what we're going to do is, now that we've cleared the cave and we know that there's no bats, we're coming out strong right behind the fast or the first pointer. And we're going to move in tandem with that first pointer as well too. Once we reach the end of the while loop, this means that the fast pointer, the first person, has reached the end of the cave. Therefore, this is where we want to do the delete. And this is how we do the delete. Now, you may be looking at this and thinking to yourself, well, how is that a delete? Second.next, that doesn't make any sense. Shouldn't we use some type of method that removes the actual node or something? Well, what's happening is that it's not so much a removal. This node isn't going away. What we're doing is we're deleting the ties to the reference. So instead of it actually referencing this individual node, it's pretty much going to go around it like this. So the node still exists, but you can't actually get to it. So it doesn't exist in a certain sense, if that makes sense. It exists, but it doesn't exist. It's a philosophical question. But here's the good thing. We're done. But remember, we don't actually want to return the dummy node. We want to return the dummy.next because this is the head. That actually points to the head, and that is what LeetCode is expecting. So let's go ahead. Let's copy this. Let's get out of full screen. I'm going to toss this code into LeetCode, and hopefully we are going to get the result that we want. So I'm going to go ahead and bring this over. Going to put this code into the editor. Let's go ahead, hit the run button. Let's test it. Tests are accepted. Let's hit that submit button and make sure our time complexity looks good. So time complexity is n. Great. Memory is constant. We have passed the interview. Hope that you guys enjoyed this. If you did, smash that like button, smash that subscribe button. And as always, thank you for watching.